Imagine pushing new code to millions of users, and nobody sees it until the exact moment you choose. If something feels off, a single switch takes the change out of harm's way in seconds. That's the promise of feature flags. They're a simple idea with outsized impact on how modern teams ship software safely, quickly, and with confidence. Feature flags, also called feature toggles, are on-off switches wired into your code. They decide, at runtime, who gets a new behavior and who stays on the old path. No redeploy required. Here's the twist that matters. Traditional releases tie code deployment and user exposure together. You deploy, and everyone sees it. With feature flags, those two moments are separated. Code can ship quietly in the background. Release becomes a controlled decision you make later, per user, per region, even per device. So why care? Because the gap between shipped and visible is breathing room. It turns risky launches into gradual rollouts. It makes A/B tests practical at scale. It gives operations a kill switch when traffic surges or a bug slips through. It's the difference between a full site outage and a tiny blip a small cohort notices for a few minutes. Think of a feature flag like a circuit breaker panel in a large building. The building is your code base. The wiring is the deployed code. Each breaker controls power to a room or floor. You can energize one wing at a time, dim certain circuits, or shut off a room instantly if there's a fault, without tearing into the walls. It's a helpful mental picture. Every feature is wired in, but a labeled switch decides when, and for whom, it gets power. Let that sink in for a moment. Now, under the hood, how does this actually work in day-to-day engineering? It starts by defining a flag and wiring it into code. A developer creates a key, something like checkout.newFlow, and wraps the new behavior in a small conditional. If the flag returns on for this user, run the new path. Otherwise, keep the proven path. The default state is usually off, and the flag is registered in a configuration system or a feature management tool. That's the first big unlock. The new code ships to production safely tucked behind a gate. So the simple version is, your app contains both old and new paths, and a switch decides which one runs. When a request comes in, the application asks a local client, often an SDK, which is just a small helper library, is this flag on for this user right now? That client evaluates rules. It looks at the environment, user attributes like plan or geography, maybe a percentage rollout, maybe a time window. Then it returns a decision. On, off, or, for experiments, a variant like A or B. The app executes the chosen path. This per-request evaluation is what turns a switch into a control panel. Product and engineering can target rules with real nuance. Internal accounts see the feature first, or only users in Canada on the premium plan, or exactly 5% of mobile users in the East region. Meanwhile, everyone else stays on the familiar path. There's a simple trick that makes percentage rollouts reliable. Most systems use a deterministic hash of a user identifier plus the flag key. That hash maps the user into a stable bucket. If someone falls into the first 5% today, they'll fall into the same 5% tomorrow. No jitter. No users bouncing in and out between sessions. There's a quiet elegance in using a tiny slice of math to create stable, predictable cohorts at massive scale. With targeting in place, teams roll out progressively. Start with the safest cohort, often internal staff or a small friendly beta group. Expand to 1% of production traffic. Watch error rates, latency, and key business metrics. If things look good, go to 5%, then 10%, and so on. What matters here is not speed for its own sake. It's shaping the blast radius. Instead of turning on a feature for 10 million people at once, you expose it to a small slice and learn from real-world behavior. If something degrades, a switch flips off and the risk recedes instantly. That same mechanism powers controlled experiments. For experiment flags, the system assigns users to variants, say a new checkout layout versus the current one, and logs outcomes keyed by variant. Conversion rates, drop-offs, load times, revenue per session. An analysis layer compares the variance and informs the decision to ship, iterate, or scrap the change. In other words, feature flags turn delivery into a measurable loop. Not just did we ship, but did it help, and for whom? There's a third use that matters during real-world turbulence: operational flags. These control heavy or risky behaviors during incidents or surges. Imagine disabling a resource-intensive recommendation module during a traffic spike or turning off a flaky integration while a partner is down. It's the breaker panel again. Cut power to the room that's misbehaving without evacuating the whole building. So far, this all sounds smooth. Flip switches, target users, watch metrics. Here's the thing that separates healthy use from chaos. Lifecycle. Flags aren't decorations. They're temporary controls. They need owners, expected end dates, and cleanup. When a feature is fully rolled out or deliberately canceled, the team hardcodes the final behavior, removes the conditional, deletes the configuration, and retires the rules. If that doesn't happen, flags pile up. The code grows alternate paths that no one remembers. Config becomes a maze of overlapping rules. Testing and predictability suffer. That's how invisible technical debt creeps in. To make this concrete, imagine a large e-commerce site preparing a new checkout flow before Black Friday. 10 million monthly users. High stakes. The team implements the new flow but wraps it in a release flag, default off, and ships the code a week early. No one sees the change yet. Then they enable the flag only for employees, roughly 500 internal users, to validate the flow against live data. Real accounts, real carts. The next step is a controlled ramp to 1% of live traffic, about 100,000 users, using that deterministic bucketing. Over 24 hours, the team monitors error rates, checkout duration, and conversion. Numbers hold steady, so they nudge to 10%, then to 50%. At 50%, a small anomaly appears, a 0.3 percentage point drop in conversion for mobile Safari. The issue is traced to a browser-specific bug in an input mask. Instead of rolling back everything, the team updates the flag rules to exclude Safari for now. Everyone else continues on the new path. The impact is limited to a slice while a fix is prepared. Put differently, the flag acted as a precision tool, not a blunt instrument. When the fix ships and validates for Safari, the team includes that browser in the rollout, reaches 100%, and, crucially, removes the flag from code and configuration the following week. That last step keeps the codebase clean for the next release. It's worth pausing on the resilience here. A simple on-off decision tied to a user or a segment can steer a massive system away from trouble without redeploying anything. There's something quietly impressive about turning global behavior with a small, reversible configuration change. Now, feature flags aren't magic wands. They move risk from code to configuration. With that shift come real trade-offs. More flags mean more branches in the code. Alternative paths accumulate. Over time, this multiplies the combinations a team has to reason about. In critical flows, authentication, billing, data pipelines, even a rare combination can cause surprises. Testing everything end-to-end becomes impossible as combinations grow. Good teams manage this by limiting concurrent flags in sensitive areas, especially short-lived rollout switches. Long-lived flags tend to live at the product edges, like plan-based features, where they behave more like configuration than temporary gates. There's also runtime overhead. Evaluating flags should be local and fast, with good caching. If your app makes remote calls to decide a flag, latency creeps in and new failure modes appear. The safer pattern is to fetch configuration in the background and make per-request decisions locally. And if evaluation fails, default to safe behavior, the one you know works. A new checkout should fall back to the old flow if the decision system is unreachable. Security and privacy deserve attention as well. Targeting rules often use user attributes, plan, region, device type. A careless rule can expose internal features, leak information about who's in which cohort, or conflict with access control. Auditing, logging who changed what and when, and limiting who can alter flags in critical areas all help avoid mistakes that are easy to make under pressure. Governance is the thread that ties this together. When a new flag is created, a named owner is assigned. The purpose is documented. An expected end date is set at creation, not as an afterthought. Automated reminders nudge owners when a flag approaches its expiry, and dashboards show stale toggles that need attention. What matters here is clarity. Ownership and intent make flags hard to ignore and easy to retire. Let's talk about the flavors for a moment, because they show up in different contexts. Release flags are the short-lived switches that hide in-progress features. They control who sees the feature during rollout, then go away when the feature is fully shipped or canceled. Experiment flags assign variants and measure outcomes. They carry extra context, event tracking, success metrics, analysis plans. Treating them like data products, not just switches, makes decisions grounded and clean. When a winner is chosen, the flag is removed and the code reflects the decision. Ops flags are standing controls for operational posture. They trim load, disable risky integrations, or throttle features under stress. These can be long-lived by design, but they still need owners and documentation to avoid becoming mysterious levers no one wants to touch. So let's slow that down for a second. There are three big benefits to keep in view: decoupled release, progressive rollout, and instant fallback. Those three create safety without slowing down. The cost is complexity in code and configuration, which is manageable with lifecycle discipline. Some common misunderstandings are worth clearing up. Feature flags don't replace testing, they complement it. Unit and integration tests still catch regressions early. Flags turn production into a controlled validation stage where real-world behavior informs the final decision. That doesn't mean skipping pre-production checks. It means adding a safety net where it matters most: live traffic. Flags also aren't just if statements you can leave forever. Yes, the implementation is a conditional. The hard part is social. Without owners, expiry dates, and cleanup, flags become invisible infrastructure. People move teams, context fades. Behavior remains mutable in ways no one quite understands. That's how incidents happen on quiet Tuesdays. And while flags make trunk-based development practical, where teams commit frequently to a main branch, short-lived branches still have a place for invasive changes. It's a spectrum, not a religion. Use flags to hide incomplete work in main. Use branches when it keeps the code review focused and the footprint contained. Operationally, a few simple habits pay off again and again. Start rollouts with the most observant cohort, internal staff, and eager beta customers who will report issues quickly. Default to safe behavior if the decision system can't be reached, especially in checkout, login, and data write paths. Limit how many active flags touch the same critical area at once to reduce combinatorial risk. And for experiments, plan metrics and event tracking up front, so decisions are made on clean, trustworthy data. Engineers often appreciate a small, subtle detail here. Deterministic bucketing means the same person sees the same variant across sessions without storing extra state. A hash function, just a repeatable way to turn an ID into a number, does the heavy lifting. It's a tiny algorithm that enables reliable experiments at planet scale. So how can a team keep this simple as usage grows? A feature management system, whether homegrown or commercial, helps centralize decisions and visibility. A rules editor that product managers can use, an audit trail for changes, alerting when error rates spike after a rollout, and a catalog of existing flags with owners and expiry all shift the practice from ad hoc to intentional. It's important, though, to keep perspective. Tools are amplifiers. The real safety comes from habits. Write flags with removal in mind. Name them clearly. Avoid nesting them deeply in the code where they're hard to find. Keep a running list of flags in critical paths and review it during design and release planning. These are small acts that preserve speed without inviting surprise. Sometimes the invisible wins are the most satisfying. A mature team flips a tiny switch and quietly avoids a potential outage. A rollout that would have been a cliff becomes a gentle slope. An experiment de-risks a bold idea and ships with evidence, not gut feel. None of this is dramatic. It just works, in the background, because the wiring is in place. If only one mental model sticks, let it be the building and the breaker panel. Your codebase is fully wired. Every feature can receive power. The panel, your flags, decides which rooms light up, how bright, and for whom. You can energize one wing at a time, shut off a misbehaving circuit instantly, and then remove breakers you no longer need to keep the panel simple. That's safe releases at scale. Before wrapping, a brief recap through the lens of our checkout example. The team shipped early with the feature off, targeted internal users, then 1%, then 10, then 50. A small issue appeared for a specific browser. A rule excluded that slice while the fix landed. The rollout reached 100%, and the flag was retired promptly. The key idea is that safety and speed came from the same mechanism: control at runtime, close to the user, guided by data. There's one last point that's easy to overlook. Removing a flag isn't housekeeping, it's design. Every retired flag returns the code to a single clear path. It restores predictability for the next change. It keeps the breaker panel readable. That small discipline protects everything else. So, feature flags in a sentence: wire features in, decide exposure at runtime, learn, and clean up. Used thoughtfully, they decouple shipping from release, enable gradual rollouts and experiments, and provide operational control when the real world gets noisy. Used carelessly, they become a tangle of hidden switches that confuse everyone. The difference isn't the tool, it's the practice around it. If this helped, a like and subscribe helps us make more of these.